Hello and welcome everyone. So I'll be explaining recent Div 3 round, Codeforces Div 3 round 713 problem D, corrupted array. So basically that's an interesting problem here. I really liked it, solving this problem. The solution is also very amazing. Let's just demonstrate the statement first. So first of all, in this problem, you're going to be given an array B which will have n plus 2 elements, and then we have to derive it how this array is actually being created. They have stated that this array B consisting of n plus 2 elements is actually being created from another array A which does have a total of n elements. So the main difference between the array A and B is the extra 2 elements that the array B hold. Okay, so the main so let's just try to understand how we actually are creating this array B. Now for the simplest part here, all of the elements in the array A will always be inside the array B. So what I only care about is how the extra 2 elements that are being created and how they are being created. That's what matters here in the array B. So array A's all element are inside array B's element. Okay, so that's it. What about the n plus 1th and the n plus 2th element, the extra 2 elements that we talked about? Okay, so the n plus 1th element will be, they have said that the n plus 1th element will be the sum of all the values inside array A. So array A's every value sum, total sum, will be considered one of the members of the extra 2 members inside my array B. And what about the n plus 2th element? This could be any number which is x, okay, any number or some number x, and that value will consist between from 1 till 10 to the power 9, and we will just simply denote it, just a random value from 1 till 10 to the power 9, and they have denoted as b of n plus 2 equal to x. Interestingly, after that they have shuffled the array. So our array B that we're going to be getting from the user, okay, so that we're going to be getting as input, it's going to be shuffled array, but it's going to be the same array B, but it's going to be shuffled. So our main task is to say whether I can make my array A, any array A, if I can make it, or if it's not possible to make it, then just output -1. So that's basically it. Remember, the given array B is shuffled. So from B, I have to create the array A if I can somehow manage to create and by manipulating the array B. So analyzing the statements and considering the facts that how B array is being created, we can have an observation here. The observation is, we know that B array holds n plus 2 element, right? And we also know inside these n plus 2 elements, apart from the extra 2 values, the other n values are all considered to be inside array A. And the n plus 1th and the n plus 2th values that are being produced of each of them, n plus 1th value is being created by sum of the whole values of A. So that's a very major observation, because that's what makes us getting into the solution. Now again, we're saying that n plus 1th, one of the values will be what? Sum of all the values of A. Now also I have to notice that each and every value is greater than 1, okay? No value is negative. So that's a bit of observational thing that, okay, so I can easily say that, okay, this might be some value which is far greater than any of them, because I'm actually this n plus 1th value. This could be a very great value, a greater value, higher value, unlike any of the values of A, because all of the values inside array A is positive. So if I sum it, the value becomes a larger. So what I thought as, okay, sorting the array B might be a positive option here. So what I will do is sort the array. Now, after sorting the array, I know, okay, so there might be a chance that I can get my n plus 1th element, which is the sum of all the elements of A, at the rightmost places. Let's say this is my rightmost places. Okay, now I can say that yes, this could be one of my rightmost places, and I can assure that this could be one of the possible answers. This could be one of the possible n plus 1th value. Okay, but there is a condition. They have said that the n plus 2th value is what? X. And now here comes the tricky part. N plus 2th value is X, but when you compare, this X value is fully independent. It's totally random. So because it's random, I have to compare this X with that sum value. Okay, now so they have said that output any of the possible value of array A. So what I will do is I will try to compare, okay, my X is this, and I will say that yes, I know that my possible answer could be the rightmost value, or it could be the rightmost value minus 1, which means the immediate the determinational value just right before the terminational value and the terminational value. Any one of these indexes value could be my desired n plus 1th index. Why I'm saying about this index, n minus 1th index? Why? Because the reason is I know that my X is X. Remember X? What I said? X is the n plus 2th value, which is completely random. Now, as it's completely random, it could be less than my n plus 1th value, or it could be greater than or equal. Okay, so I am taking all the conditions, both of the conditions. So if I consider both of the conditions where X could be, I don't know X, but I'm trying to find out. So in order to find out, I have to consider all of the circumstances, all of the conditions to follow. So that's why I know my n plus 1th sum, okay, my n plus 1th sum will be a very greater value, but I have to consider my X. This X could be less than my total sum, or the n plus 1th value, or it could be greater than or equal. What happens if this X is less than sum? Now just imagine, if this X is less than sum, then I definitely know that the rightmost value, which is the largest value after sorting my array B, this will be my desired n plus 1th value. Of course, it has to be. It has to be. Okay? If I could somehow, just imagine, if I could somehow find out that X is less than sum. I'm not figuring out. I'll tell you how I'll be figuring out, considering with both of the conditions. But I'm just saying, just imagine if X could have been less than, if X had been less than sum, then definitely the rightmost value would be my n plus 1th value in the B array, right? Of course. How about, what if X was greater than or equal to sum? If X was greater than or equal to sum, you know that X will be the rightmost value. So if X is the rightmost value, then definitely n minus 1th index's value would be my sum, because I know the sum is very greater than the rest of the values of A. But it could be less than X, which is a random value and independent too. So I hope you get that. So I'll be only checking the last two indexes, all the conditions that I'm going to be checking for the last two index. Okay, so that's my main goal. And so the problem then boils down to the last two index. So I'll be only considering for the last two index. How am I going to do that? Now that's the question here. How am I gonna consider the fact? Now, imagine first I will check, okay, if both of these cases my condition is not fulfilled, then answer will be -1 as usual, they've said. Now, first of all, I will you could try from any of the indexes, that's your wish, but let's try. We know that we're going to be manipulating only the last two indexes, okay, the terminational two indexes here. First we'll work with this index. If it doesn't happen, if I don't find out my n+1th value and n+2th value, then I will consider this one as my manipulating option. So let's start by asking here whether this is, and imagining this as the n+1th value. Just imagine. So if I imagine first case, if I imagine the last index as my n+1th value, which is the sum of the array, then I know it's the greatest one because I've sorted the B array. Now, how to make sure that there is a possible X inside the rest of the values? It's possible. How it's possible? It's possible if you have a prefix sum out of all the values, not just prefix sum, if you could have a sum value for the rest of the values. Let's say I have a B array of n+2, total n+2 values. Out of them, I will initially try to find the sum of n+1th, whole n+1th value. Okay? Whole n+1, total n+1 value sum is going to be, I'll try to find out and then inserting in my variable initially, which is going to help me in order to find whether I can make n+2th value as my like sum of the whole array, okay, considering the fact. So I hope you get that. So what I'm considering, first of all, I'm considering the last index, making it, okay, let's assume that it's the sum of all the arrays. If it's that, and how to make sure that I'm gonna get my proper X, I will have this sum. Apart from this value, I'm telling you, apart from this value, I will have the sum of the rest of the value. And then what I'm going to be doing is, now what I have denoted here, the last value is denoted as the sum of the array A. So if I could check, apart from this index, apart from the last index, the rest of the indexes, if I could just check something like this. Inside my sum, there is a sum from 1 till n+1 values of B. Okay, and I will check whether this sum minus each and every index. I will denote, okay, this could be my possible X. If it's not possible, then this could be my X, this could be my X. Okay, I'm considering each and every indexes from 1 till n+1 and denoting what if this is X. Okay, just like that. So what if this is X? What if this value is X? If this value is X, then you know that apart from that value till n+1th value, there are total n values, and their sum should have to be, it definitely have to be the last index, which is the sum that I'm considering if it is a sum. So inside my if function, I will say that if my sum minus any of the indexes from index 1 till n+1, if I consider that value as X, just like that, AI equal to X, if I consider it as my X, then I will check how to consider it, how to make sure that this is my proper X, and if I could somehow find out, which is by doing that sum minus X, whether sum minus X equal, I think I better do that, denote that B, okay, B of n+2, okay, B of n+2, of course, because I'm considering my B of n+2 is, I know that my B of n+2 is A, sum of all the values of my A array. So if this value is equal to sum minus X, where this sum is denoting the rest of the value apart from what? The last index of B, last index value of B, minus any of the possible indexes where I'm considering what if this is x. Is it possible to make x? Is it possible to make that index x? That portion will be considered for all the indexes from 1 till n plus 1, and just trying to make sure whether I can make it as x or not, whether I can make it as x or not. If it's equal somehow, if it's equal this, then I know I have got my solution. I've got my x, I've got my if I've got my x, then I'm definitely sure I'm gonna get my n plus 1th, n plus 2th element, because this is exactly what my n plus 2th element is, and I know my n plus 1th element is the last index of the B. Okay, this is possible. What if any of the indexes does not match to be x index? Then I will try another option. It is possible that sum of all the arrays, which is the n plus 1th element of the B, could be at an index where it is just right before the terminational index, which is n minus 1th. N minus 1th, n plus 1th in the comparing to the B array. Okay, which is, let me explain you a bit clearly, taking a new color. So far we have actually been trying to manipulate and trying to make this index as my n plus 1th element, right? What if I cannot make it? What if I cannot make it? Then I have another choice. This value could be n plus 1th element. So I've already told you I will only manipulate only for these two indexes. If any of these cases does not happen to have executed, then definitely the answer would be -1. Now my second term, what is it? If I make this value as my n plus 1th index. So if I make this value as my n plus 1th index, just assuming, okay, this is my n plus 1th value, which is the sum of all the values of A. Then what I only have to care about is check whether the rest of these parts sum is equal to my n plus 1th value. If it's equal, then I know that my x is lying in the last index. Remember what I told you, x could be, as x is random, so x could be greater than the n plus 1th index's value, or could be less than n plus 1th index value. For these two conditions, we're actually considering these two indexes. That's all, nothing else. So just these two conditions that we have to take care of. And let's give you an example here, you understand more. Let's see, 2, 3, 7, 12, 2. Okay, 2, 3, 7, 2, 3, 7, 12, 2. Now if I sort the array, my first task would be to sort the whole array like that, and then what I will consider is, let's consider first this index. You never know, anything might be. So if I consider this value as my n plus 1th index, then I know, okay, this is the right before the terminational index. So this sum have to be equal to this if I want to make A. So let's just do the sum. 3, 4, 5, 6, 7. Okay, it is 7. So if it is 7, then one of the possible arrays I have got it. What is it? That value is my n plus 1th index for sure. Then where is my x? X is there. Simply, as simple as that. So I'm actually finding out my array, which is 2, 2, 3, basically. 2, 3. Okay, here output could be any of the two, either 2, 2, 3 or 2, 2, 3, 7. How the answer is 2, 3, 7, I'm showing you. But one of the answer can also be 2, 2, 3. There's no doubt about that, because I'm first considering this index. What if I consider this index as my n plus 1th value, right? If I consider this value as my n plus 1th value, then I know I have to make sure, and I have to make x, whether I can make this index as x, or this as x, or this as x, or okay. So just let's just figure it out. So here 12, the total sum till from 2 till 7 is 7, 10, 12, 13, 14. I know it's 14. Okay, now first considering this index. Okay, can I make this as x? Okay, to check it, let's sum minus x, which is what, 2. Is it equal to the last index? Yes, it is. 14 minus 2 is simply equal to 12, which is the last index, which means I have found out successfully accomplished my task to find out my x, which is my n plus 2th element inside my array B. If this is my n plus 2th element, then I know that my array element is 237. Absolutely, because I don't need to draw out or print these two elements. I only need to print the array A, the desired array A, from where the array B can come. So it can come from two possibilities ways. It might happen that none of the ways is possible to come out the solution of array B. Then the answer would be -1. I hope you get that. Let me take you to the code part here. Here we have taken element n, and this is the array B, taking the element as B and then sorting the array B. After that, this is what I've told you. Actually, this index here goes as a zero-base index, so you have to be a little bit of care about here. If you want to make it one index, it doesn't matter. Any formation you can do that, but I did here as zero-base index. So this is actually referring to the sum of from index 1. If I demonstrate as one base index, then index 1 till n plus 1. Okay, n plus 1 elements sum. This is the first value where this is the first task or the first case when I'm considering the last value as my n plus 1th element, which is the sum of all the values of A array. And this is the tricky part where I'm considering whether I can make it as x or not. If I can make x, then it's possible. This flag value is defining whether I have successfully accomplished my tasks to create a value or not, a array or not. So if it's not, then FL equal to 0. FL equal to 0 is meaning that no, I haven't found out yet. Okay, no problem. Then let's focus on the index where just right before the terminational point of array B, and then total sum minus B of P minus. So this is actually taking out the sum of from the first index till the n index. Okay, from the first index till the n index of the array B, and I'm just comparing whether that sum is equal to my n plus 1th index inside my B. This is the second condition that I've told you. Okay, I hope you get that. If I could find out, then just print the array B where the element refers to the array A, and otherwise definitely it's -1. And this is the first case where if the first case value, the FL value, gives 1, then I know that yes, I have found out my desired array A. Then I'm just printing that according to the condition here. So I hope you get that, and till next time, goodbye.